Okay, so for our last lesson, we're going to be talking about exponential equations. And you guys got a little bit of a taste of this when we were doing our solutions for the exponential applications. So from last class, if you do remember that whenever you're trying to solve for a variable that's in the exponent, your goal is to, number one, express the exponential equations to have the same base on both sides. And then step two, set their exponents equal to each other. If you guys wanted to use your exponent table, you could. I've kept the numbers pretty small, so we could just try them as well. So we're going to start off with a very basic example. It's question number one. So question number A says 3 to the power of x is equal to 9. Now you guys don't even really need to know any math to do this. You just can guess what that number would be. But let's say we were learning this new method that we're learning today. What I would do is I would look at the bases 3 and 9, and I would ask myself, can I make one of the bases look like the other? And in this case, I can change the 9 to 3 squared. So my next step here would be 3x is equal to 3 squared. This is always our goal. Our goal is always to try to get the bases to the same. And when you do that, you can just sort of get rid of the bases magically, and the answer would just be whatever the exponent is. So it would be x is equal to 2. Okay, getting to a slightly more difficult question. We have negative 4 to the power of x is equal to negative 64. You can take a look at your exponent table and try to figure out what can we replace the 64 with? What power can we replace it with? Marzouk? Yep, so this is going to be negative 4 to the power of x is equal to negative 4 to the power of 3. And again, when the bases are exactly the same, they disappear, and you're left with just x is equal to 3 as your answer. By the way, there are 12 questions, and each of them sort of have a different rule and a more complexity. So I'll teach you the rules as we go along. So in the next question, again, I see that now my exponent is a binomial, so it's a little bit more complicated, but the same logic applies. We have 5 to the power of 2x minus 5 over here. We're going to look at our exponent table and see, can we replace the 125 with anything? And we can with 5 to the power of 3. Perfect. So again, when the bases are the same, the exponents are the only ones that remain. And sometimes you might have to do a little bit of extra work with that exponent. So we have 2x minus 5 is equal to 3. Yep, so we're going to move the negative 5 over to the other side. It's going to become 8. And then we're going to solve that. And our answer is just going to be x is equal to 4. Ooh, yes, and I have to be mindful for those of you that are in a hub school because you're following a slightly different schedule today, right? So I think Victoria and Shagana. All right, on to the next question. So wait, I'm just gonna pause here. All right, let's keep going. For question D, we have both of our exponents or bases that are the same already. So all we need to do is we need to look at the exponents. We're going to have 3x plus 2 over here and 4x minus 1 over here. This is taking us back to grade 9 math. So move the x to one side. It'll be 3x minus 4x and then negative 1 minus 2. This will just be negative x is equal to negative 3. And therefore, x is going to be equal to 3. Okay, so I really like questions with fractions because it gets you to think. What we're going to do for this question is we have 2 to the power of 3x already. Now we have 1 over 32. So let's just for a second look at the 32. What can I replace the 32 with to give me a base of 2? 2 to the power of 5, right? So this is like saying 1 over 2 to the power of 5. Now, how can I rewrite this? So it's just 2 to the power of something. It's kind of the reverse of a negative exponent. So you know how a negative exponent gives you 1 over something? To change this back to it, it would just be 2 to the power of 5. So generally, when we're dealing with fractions, you're dealing with negative exponents. It's very easy to solve the question just by changing it to a power with a negative exponent. Okay, and now the bases are the same, so it's just going to be 3x is equal to -5. And x does not have to be like a perfect whole number like it has been for the four examples. It could be anything. And in this case, it's going to be -5/3. Yeah, it could be anything. Okay, question F. For question F, we actually have to do 2 steps because we have a 25 as a base. Can we change 125 to be a base of 25? Can we? Like 25 to the power of what is 125? You're thinking of 5 to the power of 3. So you're actually, you said exactly what I was looking for. We can't change both of these to be 25s, but we can change both of them to be a base 5. So sometimes you are required to change both of the bases, like in this example. So we're going to go ahead and do that. And this is how I'm going to write it. It's going to be 5 squared all to the power of 3x minus 2 is equal to 5 cubed all to the power of 4x plus 3. Now I have to remember, wait, does this step make sense so far? Okay, now I have to remember the rules of a power. You're basically multiplying these together and you're multiplying those together. So you can skip steps. I'm just going to write down all the steps. So in the next step, it's going to be 2 bracket 3x minus 2 is equal to 3 bracket 4x plus 3. If you wanted to just go ahead and multiply and write that down in the next step, that's totally fine as well. Okay, so this is going to be 6x minus 4 is equal to 12x plus 9. I move this over, it'll be negative 6x is equal to 13. And so I'm getting x to be equal to negative 13 over 6. Did you guys get that as an answer as well? Yeah. Example. Again, we have a 9 and 1 over 27. I've already said that whenever we have a fraction with a numerator of 1, we're probably thinking of some sort of negative exponent. But unfortunately, none of these can have a base of 9. So we're actually going to replace both of them to have a base. So I'm going to replace the 9 with a 3 squared all to the power of x over 2. Yes. Yes. Sorry, I had to think about that for a second. So this is, 3 squared all to the power, yeah, a half x, yes. So x over 2. And what can I replace the 1 over 27 with? Marzu? 3 to the power of negative 3, because that would be 1 over 3 to the power of 3, and 3 to the power of 3 is 27. Good. So I can just take the power of a power over here, and this will actually give me 3 to the power of x 2 times x over 2 is just going to be an x. And so my final answer is just going to be negative 3. You didn't have to show it this way, by the way. Once you saw that the bases were the same, you could have actually just gone straight to the answer. Sarah? Yep. Yes, you could have done that as well. Okay, question number H. I'm going to change both of these to a base 2, but I have a negative 8, so that means I'm probably going to need a base negative 2. So I know to replace the negative 8, I'm going to change it to negative 2 to the power of 3 all to the power of 2x plus 1. So squished for space here. So negative 2 to the power of 3 all to the power of 2x plus 1. And in this case, I have negative 1 over 32. So I can actually change that to negative 2 to the power of 5. Sorry, negative 2 to the power of negative 5. Does that work out? Negative 2 to the power of negative 5? Yep. Marju? Yes, you could have in this case. Yeah. The only thing is if you leave the negative outside the bracket, then the bases don't match. And you need the bases to match in order to get rid of them. So you'd have to keep it in. Bea? I could, it's just, for me, when I write it like this, that's incorrect, right? Because then the -5 only applies to the 2 and not the negative sign. So I want to make it clear that -2 is the base completely, and the entire thing is to the power of -5. So writing it this way would actually not be correct. Yeah. And also remember, part of the whole lesson here is we want the bases to be the same. So you would want to, yeah, that was for the other question. Okay, so now I have my same base here. So I'm going to go ahead and do a power of a power. This is going to be 6x plus 3 is equal to -5, which is going to be 6x is equal to -8, and x is going to be equal to -4/3. Question I actually has an additional step. Do you guys recognize that 3 is actually the base in this question, but 5 is the coefficient? And when you have a coefficient, it doesn't actually, it's not attached to the power and the base at all. The 5 is a completely different number than 3 to the power of 3x minus 5. So what we can do is we can actually move that 5 to any side of the equation. So what I'm going to do is I'm going to move the 5 to the other side of the equation, and I'm going to divide it by 15. When I do that, what's going to happen is you're going to get 3 to the power of 3x minus 5 is equal to just 3 to the power of 1. So just make a note to yourself that when you have a coefficient, the coefficient is allowed to move freely. It's not tied down to anything with an exponent because it's a number all by itself. Sarah? So when you like for this question, when you're making coefficient in this case. So then we end up with 3x minus 5 is equal to 1. And then that's an easy solve. It's just going to be 3x is equal to 6, and x is going to be equal to 2. I would say questions J is fine, but K and L are probably the most challenging. So let's finish off with those. Yeah. Yeah, I basically, like, in order for me to get rid of the 5, I just divided this by 5. Oh, we would give you questions that work out because you would need the basis to end up being the same. Okay, so the same thing with question J, 72 is a coefficient. So we can move it to the other side and go 2 over 72. So when I do that, I'm going to get, actually use this color here. I'm going to get 6 to the power of 3x minus 5 is equal to, and 2 over 72 is the same as, what's 72 divided by 2? 3, 6, 12. Yeah, so it's going to be 1 over 36. Okay, this is great news because 36 works really nicely. This is going to be 6 to the power of 3x minus 5. What am I going to change the 1 over 36 to? Yep, you got it. 6 to the power of -2, and now it's all the same as the previous questions. -2 plus 5 is 3, and so x is going to be equal to 1. Okay, like I said, questions K and L probably the most challenging. I'll give you guys just a second to do J or catch up on J. All right, so in this question, I would say the reason why I keep saying it's challenging is because if you notice, there is an x in 2 different powers in this question. So how exactly can we do this? We can't really add these together. We haven't learned how to do that, and there is no way to do that. We can't move a coefficient to the other side. So the strategy we're going to use is similar to what we did a couple of classes ago for the transformation lesson. So do you remember when we were learning this part right here? And remember how we, for a question like this, we took 2 to the power of 3x plus 1 and we split it up? So we're going to be using that concept to solve the questions in this example over here. So what I'm going to do is I have 2 bracket x plus 3, and anytime I have something like this for a question like this, I'm going to split it up and write it as 2 to the power of x times 2 to the power of 3 minus 2 to the power of x is equal to 28. Okay, now we have to recognize that in this question, these two numbers are one term. They belong together, so they're multiplied together. So I can actually keep them together and I can solve 2 to the power of 3, which is going to give me 8. So 8 is the coefficient times 2 to the power of x minus 2 to the power of x is equal to 28. Okay, just for a second, let's say I replace, and you don't have to write this part down, but I'm going to replace a with 2 to the power of x. So when I do that, I'm going to end up getting 8a minus a is equal to 28. What is 8a minus a? Just 7a. And the reason why I'm allowed to add the a's together is because they're like terms. So the purpose of me doing this is I want you to recognize that when you have 2 to the power of x minus 2 to the power of x minus 2 to the power of x, that's kind of like saying 8a minus 1a. Those are like terms, and we're allowed to add and subtract them together because they have the exact same base and the exact same exponent. You can only do it when it has exactly the same power. If it has different powers, you're not allowed to add them up. Marju? We're not allowed to multiply a coefficient with the power. So you cannot multiply 8 times 2 to the power of x. You can't make it a 16 to the power of x. So you have to keep it separate. Yeah, so that's a good question. The question was, can we multiply those together? And you can't. So all I'm going to do is I'm going to take 8, subtract 1, which is going to give me 7, 2 to the power of x is equal to 28. Well, there's technically in front of the 2 to the power of x, there's a coefficient of 1 for 2 to the power of x. So if you replace 2 to the power of x with another letter, it would be like 8a minus 1a. Yes, is the coefficient of 1. Exactly. And now, because the 7 is a coefficient, we're allowed to move this question. So this is going to become 2 to the power of x is equal to 28 divided by 7. I'm just going to write that down so that if you're looking at your notes later, it makes sense. And that is going to give me a 4. And now this is super easy to solve because it's just going to be 2 to the power of x is equal to 2 squared, and x is equal to 2. So for question L, I'm going to split up both of those. So it's going to be 5 to the power of x times 5 squared minus 5 to the power of x times 5 to the power of 1. And negative 4 is just a constant. So I can throw it over to the other side and it's going to become a 4. Then over here, I have 25 times 5 to the power of x minus 5 times 5 to the power of x is equal to 4. We recognize that because both of the terms have 5 to the power of x, it's kind of like terms. So you're allowed to add the coefficients together or subtract them. 25 take away 5 is just going to give me 20 times 5 to the power of x is equal to 4. I can move the 20 to the other side. So it's going to be 5 to the power of x is equal to 4 divided by 20. This is going to be 5 to the power of x. I'm just showing every single one of my steps. This is going to be 1 over 5. 5 to the power of x is going to be 5 to the power of negative 1. And therefore, x is equal to negative 1. Question? Oh, sorry, I thought I saw your hand up, Marzu. Did that question, was it a little bit easier now that you've seen question K? Yeah? Okay, great. So you'll be able to recognize it when you see it on the assessment. All right. Yes. Yes. Yes, yes, yes. For sure. That's if I'm giving you a question like this on an assessment, for sure the bases will end up being the same. So you guys, your homework for this part is just that handout that I've given. I wonder if I have it here. I must. Yes, there you go. So I'm gonna just put this for you guys at home to take a screenshot of. I actually think it's also posted on Brightspace, so you can get it off Brightspace as well.